Hello, this is chapter 20, exercise 31. This is an example where you have a small sample and you do need to use um, the plus 4 method because the sampling distribution is not necessarily going to be a normal curve in this case. But like I said on the test, this I won't have any plus 4 method questions on the test, but since it's in the homework, let me explain how it goes. It says testing the waters. In August 2010, the Columbus Dispatch took water samples at 20 Ohio State Park swimming areas and tested for fecal coliform, which are bacteria found in human and animal feces. Experts warned that the tests are a snapshot of the quality of the water at the time they were taken, and levels can change as weather and other conditions vary. An unsafe level of fecal coliform means that there's a higher chance that disease-causing bacteria are present and more risk that a swimmer will become ill. Of the 20 swimming areas tested, 13 were found to have unsafe levels of fecal coliform according to state standards. Assuming the swimming areas tested represent a random sample of swimming areas throughout the state. Okay, so if you were going to compute a p-hat here, so this is chapter 20 exercise what was it there? Question 31? Okay, exercise 31. All right, so it says that out of 20 swimming pools, 13 had fecal coliform in them. So that would be 13 out of 20 is your p-hat. Now, what exactly is a success and failure in this case? So remember, success and failure, those terms in statistics are just labels. Success is not necessarily good. Failure is not necessarily bad. But in this case, a success is that you found fecal coliform. All right, I'll just abbreviate here. You found the fecal coliform in the water, and we had 13 of those. And then the failure is you didn't find it, and we had 7 of those. Just subtract. There's 20 swimming pools altogether, so 7 out of 20. So subtract, you get 7 left. Okay, now let's go to the textbook's explanation of this. This is on page 497 of the book. It says the large sample confidence interval for a population proportion. So it says draw a simple random sample size n, and you have your confidence interval formula right there. It says where z star is between blah blah blah. Okay, right here it says use this interval only when the numbers of successes and failures in the sample are both at least 15. All right, well, we don't. We don't have at least 15 successes. We don't have at least 15 failures. So that's the answer to part A. So back to the question here. Part A, it says, show that the conditions for the large sample confidence interval are not met. Show that the conditions for the plus 4 interval are met. All right, well, we don't have at least 15 successes and failures. Okay, don't have at least 15 successes and failures. Now, I mentioned that some statistics books say all you need is 10 successes and failures. And even then, you only have 7 failures here. So even then, it wouldn't have met anyway. So what this is telling us is that the sampling distribution is not quite close enough to a normal curve. All right. Now for part B, it says go ahead and do the 90% confidence interval using the plus 4 method. So I'll go ahead and do it here, although I'm not requiring that you do this. But the p-hat here is 13 out of 20. All right. So if you use the plus 4 method, that means we're adding 2 imaginary successes. So add 2 imaginary successes, that's 15, and then add 4 individuals altogether. So then you have 15 out of 24. And then calculate that p-hat. Let's get our handy calculator here. 15 divided by 24 is 0.625. Okay, and then from that point on, you use that for all the p-hats and all the formulas. And so the formula here for confidence interval is p hat plus or minus z star times p hat 1 minus p hat over n, parentheses, square root. And so p hat is 0.625 plus or minus z star, it says 90%, so that's 1.645 times square root 0.625 times 1 minus 0.625, which is 0.375, divided by n. And by the way, use the new n also, 24. Okay, now do that calculation. So that's going to be 0.625 plus or minus. Okay, let's go ahead and multiply here. 0.65 times 0.375. So I've got my 0.65 already. Times 0.375 equals 0.23. Divide that by 24. I get 0.009. Here, let's move it down so you can see this better. Take the square root of that. I get 0.098 times that by 1.645. 1.645. And I get 0.16. So there, 0.163. I'll round off 3 digits here. So 0.163. Okay, that's my margin of error. So that's a huge margin of error. And this is only 90% confidence. So that's the drawback of such a small sample. Sample size 20. Very big margin of error. So we're 90% sure that the real percentage of swimming pools that have fecal chloroform is somewhere between 62.5% plus or minus 16.3%. And that is it. Now, by the way, for the homework, when you're doing your homework, if you just use 13 out of 20, I'll go ahead and just, although technically it's better to use the +4 method in this case, but it's okay just to use this number just for homework purposes. All right, that is it for this question.